Welcome to Physics with Mr. Brazil. Today we'll be learning component vectors. This is a two-part series, so we're going to start with part one. And let's start with this question. A person walks 5 kilometers at 75 degrees from the horizontal, then changes direction to walk 3.5 kilometers at 25 degrees from the horizontal. What is the person's displacement and direction? Well, to do this, let's use the two vectors first to build some smaller triangles and make sure the vectors are tail, head from one another. Now, here's what I mean. We're going to make little triangles. What we can do is we could put a coordinate plane to get our thoughts organized. I tend to give that advice to my students. And then we can do a horizontal component for each vector. And then also produce a y component, the gold arrows, to make little small triangles for each vector. And therefore, the vector is the hypotenuse also. Now, we can transpose the x component of the 3.5 downward, and that will be a side of the resultant vector, the horizontal portion of that vector. And we could also transpose the y vector for the 5 kilometer. That'll make the side of the y component for the resultant vector, which is the red arrow, which we always start from the tail of the first vector and end at the head of the last vector. And that's our resultant for any number of component vectors. I'm just using two vectors today. Now, here's what I tell my students. To add these vectors, build a table, x component and y component. We take x1 and we write the math for it. That triangle has a hypotenuse 5 kilometers, so that'll be times cosine 75, which will give us 1.3 kilometers. So that's the distance for the x1 component. We do the same thing for the y1 component. We take the 5 kilometers times sine, okay, the opposite side of the triangle, and that will give us 4.8 kilometers. We do the same thing for the 3.5 kilometer triangle, which we have the x2 equal to 3.2 kilometers and the y2 equal to 1.5 kilometers. Now, if this is moving too fast, just stop the video, rewind, give it a shot at trying to understand this. Next, we're going to add this. I'm just going to put a big, huge horizontal bar and add each component. So I'm going to sum all the component vectors for the x and all the y components for the y side of the resultant triangle. Now, I bet you can figure this out. We're going to use Pythagorean theorem. Using Pythagorean theorem, we can find the resultant vector. That's the red vector. That's the one that we're looking for. That's going to give us our displacement. We put in our values for our sums for x and for y, square them, square root, and you're going to get 7.7 kilometers. So the displacement from the original position to the final position is 7.7 kilometers. Now, to determine the angle, we just take the arc tangent, make sure you put y over x, okay, 6.3 kilometers and 4.5 kilometers. I like to put units so folks can determine where I got the values. The units will cancel. Use your calculator and you will determine that is 54 degrees. Now, you could answer this in this manner. You could write a little statement, but the proper way to write this would be the displacement is 7.7 meters at 54 degrees north of east. So we use compass directions, and part 2, I will teach you how to do that. Okay, enjoy physics and have a great time with it. Until next time.